So this is another part of 11.1, simplifying radicals involving fractions, and instead of talking about the multiplication property of square roots, we're going to talk about the division property of square roots. Okay. With the multiplication property, that was the one that said if we take the square root of a number, we are allowed to separate it into the square root, or the product of the square root with factors. You wrote down yesterday the square root of 54 could be separated, for instance, into the square root of 9 times the square root of 6. So they're saying you are allowed to split these up into separate radicals. What the division property says is if we have a fraction inside of the radical, which is one of the things that we want to simplify out, leaving a fraction inside is not allowed. Just like we can separate it in multiplication, we can also separate it in division. So if it serves our purpose to separate the two, then that's allowed. It's still division, but it's easier to take the square root of these separately sometimes than it is the whole fraction, because we don't want the decimal inside if we're simplifying. So these happen to be perfect squares, so we could take that a step further and say that's 4 over 5, taking the square roots separately. Okay, so this is an instance where separating it into two radicals puts us in a better position than leaving them together. Now, along the same lines, we can also put two separate things back under the same radical as long as we leave it as division. For instance, if you have the square root of 24 over the square root of 6, each one individually, may or may not be able to be simplified, but if you look at the whole fraction, look at the big picture, you see 6 goes into 24, so it is better for us to actually put it back together and say that's the square root of 24 divided by 6, because we can divide 24 by 6, right? So we do the division, we get the square root of 4, which is 2. Okay, so you kind of have to check two things and see which one puts you in a better position, and that's what kind of drives the direction that we go. If it's better to have them together, we leave them together. If it's better to separate them, we separate them. So it can go both directions. That's basically what this property allows us to do. Okay, now I'm going to have you write down a couple things in general, and then we're going to look at some examples which illustrate which of these things are better to do. Okay, so when you see that there's a radical involving fractions, you're going to check these things, these possibilities. Okay, the first thing you want to look at is there a perfect square in the denominator? For instance, 11 over 49 in the radical. If the answer to this is yes, there is a perfect square in the denominator, then what we're going to do is separate into two radicals and simplify each separately. So I would separate this into two. Oops. The square root of 49 on the bottom is 7. And what happens with 11 on top? It stays the square root of 11. We can't simplify that, right? Mm-hmm. Okay. Now sometimes you will be able to simplify the one on top, sometimes you won't. But one of the rules we are ultimately going to get to is that you can also not leave a radical in the denominator. So the first thing, one of our first goals is not to leave a radical in the denominator. If you can avoid that from the beginning, that's your best situation. Okay, the second possibility. If there's not a perfect square in the denominator, you want to look and see if the fraction has common factors top and bottom. So basically if the fraction can be simplified, or if the numerator, which is your top number, is divisible by the denominator. So does the bottom go into the top? All right. So if your fraction can be simplified, or the bottom goes into the top, and you get a whole number, then we definitely want to do that. Okay. Sometimes that will involve putting the two numbers back together to do that as one radical, or doing it before you split anything up. If one of these is the case, then what you're going to do is simplify the fraction before you really worry about the radical. So simplify the fraction first. Then simplify the radical. Yes. Oh, yes. Sorry. Okay. An example of a fraction that can be simplified. Okay. These might be apart, they might be together. But you'd want to look at the whole fraction, regardless of where the radical is, because you can put them together or apart. Okay? But look at the whole fraction. You should notice that 11 goes into 88. So it wouldn't make sense to split these apart. We might as well do 88 divided by 11, which is square root of 8. You do still have to make sure that your radicals are simplified. So we know that 88 is 2 times 2 times 2, right? Or you could do factor tree to figure that out. So the pair of 2's should come out of there. So my final simplified answer would be 2 radical 2. Okay. So the simplifying part that we've already done, you still need to continue to do that. That's like learning how to add and subtract fractions. You add and subtract your fractions, but if your final fraction can be reduced, you should reduce it. It's the same way here. We take care of the fraction part, but if we end up with something that can still be simplified, you need to continue on. All right, so we're going to do a couple examples in this area. And then we're going to talk about what happens when a radical does end up in the denominator after we've done everything we can do. Okay, so more examples are going to be in part 2.